Hello, today we're going to cover Business Calculus, section 3.3, which is all of the word problems. Yay! So we use our new derivative skills to optimize situations. So we learned all this stuff about their graphs, and we always found that that first derivative found the maximums and minimums. And those are important in real life because we generally want to minimize cost, maximize revenue, things like that. So here are some of the situations where we might see that occur. So in this first one, we have a farmer. He built this fence. Now it's a little bit weird. Instead of just a regular rectangle, he needed to separate two different kinds of animals or whatever. So he has this amount of fencing to build two identical rectangular enclosures that can share one side of the fencing. So let's label these. So if I called this side X, then all three of these would be that same exact length X. And then if I called these Y's, then I could call these sides Y. It says they are going to be identical, so that means each of these Y's would be the same as each other. And it wants me to maximize the area with my limited amount of fencing. So I'm using my 1,700 meters of fencing. And to build this shape, I would need to build three lengths of three sides of the fence of length X, there we go, and 4 sides of the fence of length Y. Now we know we're going to be maximizing the area, and the area is always found with the length times width, but be careful because I do want to build all, both of these enclosures, so all 7 sides here. So the area is not just going to be our normal length times width, it's going to be the X times the Y, and then it's going to get doubled. Okay, because I have 2 of them. So this X times Y is the area of this one, but this X times Y is the area of that one. There are 2 of them, not squared, because I'm not multiplying area times area. It's area plus area. All right, so I can't solve this, of course, since I have 2 different variables. So let's narrow this down. I'm going to isolate this in terms of X. So I'm going to bring my 4Y over. So I'd get that 1,700 minus 4Y equals 3X. And then divide everybody by 3. Now, unfortunately, this is not evenly divisible by 3, so I do have some fractions, but don't worry, it's all going to work itself out. So I have 1,700 thirds minus 4 thirds X. So 3 right there. Okay, sorry, Y. Why did I write X when I meant Y? Okay, 4 thirds Y. There we go, equals X. There we go. Okay, now I can break this down in a way where I have one variable only. So I know that there are 2 sides of that fence, but this time I'm going to replace the letter X with this whole big thing, 1,700 thirds minus 4 thirds Y times this Y. So be careful, don't forget there's 3 things here, the 2, the X, and the Y. I just replaced the middle X here. So I'm going to clean that up a little bit. I'm going to distribute the 2 and distribute the Y. So that would give me 1,700 times 2. Let me just double check myself. I'm pretty sure I know. Yep, 3,400. Okay, so that'd be 3,400 thirds, still not evenly divisible by 3, Y, because I'm also distributing the Y, minus 8 thirds Y squared. Okay, now I could have gone either way with either variable. I just happened to choose this way. Okay, now I am going to take the derivative. We're in calculus, it's all about derivatives. I could not take the derivative before because I had 2 variables. So if anything, I would have had implicit differentiation. It would have been weird. So we wanted to narrow it down to 1 variable. So this is now A as a function of the letter Y. So I'm taking the derivative with respect to Y. This, of course, would just be that constant, even though it's a weird constant, of 3,400 thirds. This one I would go 8 thirds times 2, which makes 16 thirds. And then this would go down by 1, so it would just leave a Y. We always find the maximums and minimums by setting the derivative equal to 0. Okay, Okay, so if I set this equal to 0, then I can start isolating the y. I could add the 16 thirds over to the other side, which would leave me the 3400 thirds equal to that 16 thirds y. And then I could divide using my calculator as long as I'm careful with parentheses. You may also have noticed that those 3's could cancel. If you did, that makes things even easier on you. As long as you have those parentheses, it works itself out to give you the 3400 divided by 16 is 212.5. Let's go and make it a fraction because fractions are always better. And that's going to give us 425 halves. Okay, now be careful that you answer the question. So this one wanted to know the dimensions. So that means it wants the x and the y. So we just found the y, we need the x. And remember from right here, that the x was equal to this big messy fraction minus 4/3 times y. So I'm going to do just that. 1700 thirds minus 4/3 times this answer we just got of 425 halves. Okay, so that's going to give me the x, and that worked out in the calculator would give me, let me figure that really quick. Fortunately, not one I know off the top of my head. But when you type it in, it is a decimal, turn it back to a fraction, and it's 850 thirds. Okay, so it'd be slightly weird dimensions on his fencing, but it works out. I'm sure he'd do a little bit of rounding. But if he wanted the absolute maximum area, that's where he would need to go. Now the last part of the question does ask for the area, but be careful right here, and it will be just like this on your homework. I wanted the area of each enclosure, not the whole thing, so I'm not going to plug it back into area, because this was for the total area for both of them. So for area of 1, let me write it out here. Not of both, but area of one of them, I would do just x times y. So I would take just the 425 halves times the 850 thirds. And of course, it's going to give you a weird decimal. You could make it back into the fraction again, or in this case, let's just go and leave it as that number. So we take the 850 thirds times the 425 halves. I get the big, crazy number of 60,208 with a repeating 3. And the reason I left this in decimal form is because technically in this scenario, I probably would have had them all in decimal form, but since I kept using these numbers to find more answers, more mathematical answers, I kept them in their more exact fractional form to avoid rounding errors. So I kept everything as fractions until I was all the way done. But this is the final answer, so now I went to decimal form. So that was my reasoning. Okay, now this one we want to maximize the volume of a box. Now what's happening is they gave us a flat piece of cardboard. So we've all been in this situation before, right? Trying to build a box for Christmas. Christmas is coming, I can't wait. No matter when you watch this video, I'm still waiting for Christmas because I always love Christmas. I do listen to Christmas music in July. I'm one of those people. Now the way that they recommend that you set up this problem is that in this rectangular piece of cardboard, it's not a big square, we always have to cut out square corners no matter what, because otherwise our flaps are going to be wonky. So we always need squares, perfect squares, which means we can narrow this down to one variable in one quick, swift step, because these are all going to be the same squares of length x. Okay, so I didn't really have to write them all, but just to emphasize the fact that they're all the same. So our rectangle has uneven sides here and here, the whole side of 9 by 24, okay? But if I wanted to know the little length that my new box would be, because once I cut this out and fold it up, this would be the length of my box. And this distance here would be the width of my box. Can you kind of visualize your tissue box? You've folded up those flaps. So these squares have been discarded, of course, but what's going to make the biggest box? Little bitty squares where we have kind of a long flat box, or a big tall skinny box, or somewhere in the middle. So this means that my length would be found by taking that whole length of 9, but be careful because I have to cut out this x and this x, so I need to cut out 2 x's. Same story for the width here, so 24 was all the way across, but I needed to cut out 2 squares to make it work. So in order to find the volume of the box, I would take the depth, which is whatever those flaps folded out, give me for little flaps folded up, times the length, times the width. So now all in terms of the same variable x, I would get the single x, which is just the depth, the length, which was the 9 minus 2 flaps, and the width, which was 24 minus 2 flaps. Okay, I'm going to FOIL these together just because then I don't have to use my product rule for my derivative. And I'm also going to distribute in this x. I believe in you. You can do it all at once. So I will use my calculator a little bit for the numbers because I don't know 9 times 24 off the top of my head. It is 216. And then that, of course, would be multiplied by this x. Then I'd go 9 times 2 is minus 18x. And then this x would make it x squared. 2 times 24 is 48x. Times another x would be x squared. And last, minus 2 times minus 2 would be positive 4. That would be x times x is x squared. Times this last one, make it x cubed. Clean this up one more time, just by combining these two like terms. And let's go ahead and write it in order, just because I like things in order. So that would make it the 4x cubed. 18 and 48 makes minus 66x squared plus 216x. Okay, now we're in a calculus class, so we always need derivatives. So this is v in terms of x. So the derivative v prime would be 12x squared. 66 times 2 makes 132 minus 132x plus 216. The derivative is always set to 0 to find maximums and minimums, which means luckily this one I can use the quadratic formula. And if you have met with me in person, hopefully you have that quad program, saves you a whole lot of time. Remember that you go to programs, you can scroll all the way down, or Alpha 9 will jump straight to those programs, or to the quad program for you. So remember the program button is right here. If you've gotten those from me, you can scroll down to quad. I hit enter to select it, enter to run it, and then I'm going to enter the A, B, and C of this quadratic formula. So that would be an A of 12, B of negative 132, and C of 216. Just like this. When you hit enter the first time, it gives you the decimal answer. In this case, these are exact numbers, so I get an x of 9 and an x of 2. And when you're running this program, notice the little dots. If you hit enter one more time, it would give it to you in exact form in a scenario where these were not already exact. Now, only one of these answers is going to work. Now, it seems like they both should, right? But think about this. Our box was only 9 inches wide, so can I use an x of 9? No. In fact, any x's bigger than 4.5 are going to be silly, because if it was 4.5, I'd cut the box in half, and the volume is now gone. So just be careful. Watch those x's, see which one is actually physically possible. So go back to your dimensions and see which one's going to work. So anything bigger than half of the smaller number is just cutting your box in half. So don't do that. I could not use any x's larger than 4.5. No, don't do that. Okay, so that means the x that I wanted is 2. It wants me to answer by saying the size of the squares cut from the corner. So the square I would cut out would be a 2 by 2 square. That's the answer they want in XYZ. They don't want the volume, they don't want the length, they don't want the width, they just want the square. If they did ask for volume, length, or width, I could just take that 2 back in and figure all that out. but just watch out, make sure you're answering their question. Now this one looks like it's going to be hard, but it's one of the easier word problems because it says blah, blah, blah equation. So it already gave me the equation to work with. So it's looking for max and min optimization, so I'm going to take the derivative. Unfortunately, I do need to use my quotient rule. Okay, here's my top and bottom, my u and v. So remember the derivative of a quotient, so that's t, is found by taking low d high, means the original denominator times the derivative of the numerator, low d high, minus high d low, the original denominator, numerator, original numerator times the derivative of the denominator. I'll get it eventually. Tongue twister here. I'm just a math teacher, can't do tongue twisters. All over the derivatives denominator, all over the denominator squared. So not the derivative of the denominator, the original denominator squared. Now, it looks like it's going to be a mess, but don't worry, because this is the best problem ever. Remember that we set it equal to 0 for a optimization, and we don't have to worry about this fraction, because if you remember, the way to get rid of those fractions is to multiply both sides by the denominator. Well, if I were to multiply both sides by that whole thing, t squared plus 25 squared, you would of course cancel on this side, and then 0 times anything would be 0, so it would just go away. So all I'm left with is all this in the top, so let's clean that up. 100 times t squared would be 100t squared. 100 times 25 would be 2,500, and then 2t times 100t would make 200t squared. Okay, it's still equal to 0 because I'm still trying to optimize. Luckily, these are like terms. 100 minus 200 is negative 100. And you could go about this a couple ways. You could solve it by hand by isolating the t squared and square rooting. Or since you have it handy, let's go ahead and use that quad program again with an a of negative 100, the b of 0, and the c of 2,500. Boom, answer. So if I use my quad, then it tells me that those t's would either be 5 or negative 5. But again, thinking of real life, we're not going to take drugs at negative 5 hours unless we're Marty McFly. So this is the only logical answer in a non-Back to the Future world. All right, now this last problem is my most favoriteest problem because it seems really hard. But as soon as you know the trick, it's the easiest problem of the bunch. So it gives you all this information and it's so practical. It's something you would totally want to do if you own a hotel. You want to maximize your revenue. So you found that, of course, that the price and demand fluctuating, that if you try to raise your prices, less people come to your hotel. So it says if you can normally average out renting 200 rooms when you set the price at 60, but you've done some research and you found that if you increase by $2, 4 fewer rooms are rented out. So it's this balancing act. We want to, of course, maximize our revenue, income, the incoming money. Well, the revenue is found by multiplying the rate that we charge times the rooms that we rent out. It's the money coming in. So all I need to do is try to find a way to assign a variable so that I can put all this information together. And here's the trick. So once you know this trick, it's awesome. We're going to assign a variable x to be the number of $2 price increases. Because then I can connect them all to the same thing. Okay, so for example, if I charge $62, that would be one $2 price increase. If I charge $66, that was 3 $2 price increases. Every $2 price increase, I would put an X of 1. Okay, now I can connect them all. So now I can see that the rate that I'm going to charge for the room, starting with my average, would be $60 plus $2 times X. So like I said, if I chose an X of 3, that gave me a rate of 66. 66 had 3 $2 price increases. Then I can connect that same variable X to the number of rooms. So if I rented out on average 200 rooms, but every time I increase that price, 4 fewer rooms were rented. So I went down by 4 every $2 price increase. And now they're both connected to X. So now I can put them into the same revenue function. So back to basics, the revenue was the rate times the rooms. So the 60 plus $2 price increases, and the 200 rooms minus 4 times the $2 price increases. So again, I could use my product rule, but it'd be just a little bit nicer if I could FOIL this together, save me a step. Oops. So that would be 60 times 200, which is of course 12 with 3 zeros, 12,000. 60 times 4 is 24, nope, just one, sorry, $240. Let me double check, it's been a long day. Yeah, 240. Okay, 2 times 200 is of course 400. And then last, 2 times 4 is 8. That one would be an X squared. Okay, that's 12,000. That would be plus 160 minus 8x squared. Okay, all of these optimizations dealt with a derivative with respect to the variable x, so that's going to be 160 minus 16x, 2 times 8 is 16. We always set that derivative equal to 0, which means 160 is equal to 16x, which means x equals 10. Now be careful, this is not the final answer. This leads us there. I wanted to know the rate that would maximize revenue. Well, the rate was 60 plus 2x. So if I found that it would all be maximized with an x of 10, I plug that in to see the rate I should be charging to get the most bang for my buck is $80. Now, if they did ask us how many rooms that would rent out, I would just plug that in right here. So I go 200 minus 4 times 10, which would give me 160 rooms. If they happen to ask me what my maximum revenue would be, then I would take that 80 times the 160 to see my total maximum revenue of $12,800. We should all go get us a hotel, right? So just so we can see all those pieces together, this was the rate, this was the rooms, and that would have been the revenue. All right. So in this question, it only asked for the rate. We were done, but just so we can see all those pieces together and so we can go buy us a hotel. So if you see any hotels available for sale, let me know. Otherwise, that's all for today.